Hi, I'm Dr. Neenu Garg. In this session, I will give you one more example for SJF. So let's start. In this example, we have to find the average waiting time, waiting time, average turnaround time, schedule length, and throughput. There are 5 processes in the system: P1, P2, P3, P4, and P5 with given arrival times and their CPU burst times. So let's first plot Gantt chart. From 0 to 1, there is no process in the system. So CPU is sitting idle. At time 1, P1 comes in the system and there is no other process and scheduler has no choice. So P1 will be scheduled. P1 will execute. Its burst time is 7, so it will execute for 7 time units. At time 8, all the processes have arrived in system, right? At time 3, P3 came in system which has shorter burst time than P1, but still CPU keep on executing P1 because SJF is non-preemptive. At time 8, system has a choice. Scheduler has a choice between P2, P3, P4 and P5. So P3 has the shortest next CPU burst. So it will execute till 1 time unit because its burst time is 1. At time 9, the next process that will be selected among P2, P4 and P5 is P2 because, P4. I'm repeating again, among P2, P4 and P5, P4 will be selected because its burst time is just 2 time units, which is shorter than the other 2 burst times. After P4, among P2 and P5, P2 has shortest burst time. So it will execute till 16 time units. Okay. At time 16, there is just one process left in the system, which is P5. So P5 will execute for 8 time units. That's it. Now most of the work is done. We will first fill the completion times. Completion time of P1 is 8, of P2 is 16, P3's completion time is 9, P4 is 11, and P5 is 24. Turnaround times. We know that turnaround time is completion time minus arrival time. For P1, it is 8 minus 1, which is 7. For P2, it is 16 minus 2, which is 14. For P3, it is 9 minus 3, which is 6. For P4, it is 11 minus 4, which is 7. For P5, it is 24 minus 5, which is 19. So these are the turnaround times, and you can find out average turnaround time by adding all the turnaround times and dividing it by number of processes, which is 5. So you can do this computation. I'm leaving it on you. So you will get some X milliseconds. Okay. Now next come to waiting times. Waiting time. Waiting time is turnaround time minus CPU burst time. For P1, it is 7 minus 7, which is 0. We can also verify it. As soon as P1 arrives, it was allocated. So its waiting time is 0. For P2, it is 14 minus 5, which is 9. For P3, it is 6 minus 1, 5. For P4, it is 7 minus 2, again 5. Last for P5, it is 19 minus 8, which is 11. So average waiting time is 0 plus 9 plus 5 plus 5 plus 11 divided by 2. Oh, sorry, divided by 5. That is the number of processes, which will give you some value. So you have to compute on your own the average waiting time. Next is the schedule length. All of you remember schedule length is the difference of completion time of last process with arrival time of first process. The time during which scheduler was active. So it is 24 minus 1, which is 23. Scheduling start at 1 millisecond and it ended at 24 milliseconds. So this is the schedule length, 23 milliseconds. Next is throughput. Throughput is number of processes divided by schedule length. And in this case, it is 5 divided by 23 processes per millisecond. 5 by 23 process complete in 1 millisecond. So this is the throughput. So this was another example for SDF. I hope SDF is now clear. Thank you.